Evening, ladies and gents, and good day to you. Welcome to tonight's LIDNUG event, which tonight we're bringing to you Steph on implementing analytics in your applications. Before going into the introduction, I just want to say thank you to our sponsors, which are AUXWebs. My screen's gone all over. Telerik. We have Inner Workings, Sync Fusion, Pluralsight, and WinSelect. Now, without you guys, it won't be possible to carry on doing what we do. Also tonight we have a special thank you to Steph and their community SQL relay. For those of you who have been to our meetings before, you know that we use live meeting. However, after last night, what I can only describe diplomatically as a failed test session, we've had to drop live meeting for this evening. However, Steph has graciously offered to us the use of GoToWebinar for tonight and hosted it for us. So very special thank you there. A bit about Steph. Steph is an analytics and BI professional. Recently, just in January, she was awarded the Microsoft Data Platform MVP, and she's also a community leader. Now, if you've ever been to one of Steph's presentations in person, as with all people who give their time to the community, you'll know how much passion that she has for what she does. If you want to find a bit more about Steph, you can also find her on Twitter at Steph Locke. Alternatively, there is a blog at italock.com. A bit about LIDNUG. You can find LIDNUG. You can email us at info@lidnug.org. You can find us on Twitter, Facebook, and YouTube. And YouTube is where, of course, all our videos are recorded and sent to. Of course, you can find us on LinkedIn. Now, there is a website, lidnug.org. However, due to work and life commitments, we haven't quite got it as far as long as we'd like to. This also goes for the Windows 8 app, which was promised last year. However, due to Windows 10 come along, this has been scrapped, and we are developing the UWP app, where you can learn about our presenters and look at our backlog of videos when you need to. If you do have a question, there is a panel on your GoToWebinar there to open up and you can ask a question. If it's a question directed at a member, directed at LIDNUG, there is members of staff around with LIDNUG next to their name, which you can ask them. Otherwise, if it's directed at Steph herself, we will take Steph's lead on when she wants to answer the questions. So that's been me. Stop talking now. So thank you very much, and I'll give the internet over to Steph.
Hiya folks, how are you doing today? Okay, so what we're going to do is...
I'm going to make you present.
Okay, hopefully everybody can now see my screen. Is that right, Gavin?
Yep, it's just loaded up there. I can see it now. Yep, I've got it.
Awesome. Okay, so before we begin, just want to make sure that you're all here for putting analytics actually inside your application, as opposed to doing some analytics on the performance of your application. So analytics in, not on. Feel free to reclaim your evening if you were looking forward to analytics on your application. Okay, you don't need to know a huge more about me because Gavin very kindly introduced me. So we'll crack on. So what am I looking to cover today? First of all, I want to cover the buzzwords, the things that you'll hear going around and are possibly quite meaningless to you and may end up still fairly meaningless to you afterwards. But I want to pursue actually where the value in them is, what sort of things you can do with them, and some of the technology. Now, none of this is going to be I'm not going to show you any code because I'm pretty sure you guys can all code me out to the water. So it's more practical for me to tell you how and why you can do these things, and you can go away and actually investigate the specific technologies. And once I've gone through the tech, I then wanted to look at, from implementing analytics in applications, what sort of things you might want to consider, because you want to do it right and you want to do it well. and hopefully you want to, make money out of a time investment. So we'll look at that. There should be an hour and 10 minutes of presentation. So I left a liberal amount of time for questions. Do feel free to ask them throughout. I'll do my best to remember to check out the chat window, which is over there. So if you see me looking there, that's because I'm looking for questions. So let's crack on. Okay, buzzwords. So a lot of this analytics business is what started off as statistics. So thinking back to your high school maths, this is things like Poisson distributions, chi-squared. These were things people did, often quite manually, but now they can do computationally, to look at their data and, based on a hypothesis they have, develop a model. So a model is a rule of thumb. It can be as simple as the average age of LIDNUG members is 35. So if somebody from LIDNUG comes along, asks me their age, I could say, I'm going to bet 35. And that's as simple as a model can be. But then it can get more complex to, well, they've said they're a C# developer, so that adds or knocks off 5 years. They have a beard and an undercut, so that takes off 20 years, and so on. And that would be a more complex model to arrive at somebody's age. So statistics is human directed, so we want to prove something or check something out, and we drive the development of that model. So we say what data goes in. We usually do what's called supervised learning. So we have a column that we're trying to predict. So whether it's age, so you'd get like all the LIDNUG members, put in all their vital statistics and their age, and you'd use the the information about the LIDNUG members to try and predict their ages. And we have those known values. So that's pretty much what statistics is. Analytics is basically any computational stats or calculation. It's just a general term for doing stuff with computers. Predictive and prescriptive analytics or statistic, they're usually referring to analytics. These are the sweet spots usually for where you want to get to with your computations. I'll go through the 4 levels later, but predictive analytics is where you try and predict a value. So how old is a LIDNUG member? And then prescriptive is saying, based on our models and our desired goals, this is how old a LIDNUG member should be if we get this sort of, if we aim for these sorts of characteristics. Data science is effectively the practice of doing analytics. It is the technical, the professional role. So if somebody says they're a data scientist, what they do for a living is they implement analytics. Data mining was so with statistics we had a goal in mind, and we had a column which says yay or nay. With data mining, we're trying to look for what we tell the computer to go away and find interesting facts out for us. So the classic example of this is Walmart sticking beers and nappies together, because they found that gents on a Friday night would often come in last minute to buy nappies, and they'd buy a six-pack at the same time. So they boosted their revenue by putting the two things together. And that was information. That was a relationship that was uncovered through the data. Human directed, computer derived. So then machine learning is more complex data mining, usually with the aim of predicting another value. So you'll often hear about neural nets. Neural nets are a specific type of model that basically they start off with some ways of some simple if this then that, and they build these up into a complex network of predictions to derive a value. So usually with that, we don't actually tell the computer which features to include in the model. So with statistics, when we're trying to predict a LIDNUG member's age, we might say, I'm going to use their profession, whether they're a hipster, and that might be it. That might be all I need to predict relatively accurately their age. With machine learning, I might put in all the features I can grab out of your LinkedIn profiles. And then with machine learning, it'll calculate lots of different variants and build up a more complex view of how to predict a LIDNUG member's age. Artificial intelligence is taking machine learning and using it to basically make computers act like people. It's how do we make a computer behave, do something like play Go. And deep learning is a subset of machine learning, which uses typically lots of neural nets. So deep learning is why I have this crazy version of my picture. This is Google Deep Dream, and it's based on their deep learning algorithms, and people have been making lots of pictures or teaching computers how to make paintings like Van Gogh. So that's what I was thinking. And you can upload any picture and try it out on deepdreamgenerator.com. Okay, so those are the buzzwords. Basically, it's all just fancy words for some way of modeling and predicting something. And using computers is analytics, and the people doing analytics for a living are data scientists. And the really neat thing is that, and there will be a lot of cartoons. I really like cartoons, so you guys have to suffer through it. As we get better with using computers to do these cool bits of statistics and machine learning, we're able to put analytics in more places. So you can, at the last Professional Association of SQL Server Summit, they brought up fog computing. So cloud computing was previously where all your devices would stream all their data to the cloud. Analytics and stuff might happen then on all that data. So all the devices just pushed stuff and compute happened in the cloud. Now we're able to start actually putting some of the analytics in the devices. So we can predict and prescribe actions actually on the device and only push a few values. So the compute is distributed. And this is good because it seems really silly to send lots of data over a network just to calculate a value and then maybe send that value back. And gotta love Dilbert. Machine learning, it's really overhyped in the sense that it is effectively just doing some statistics and just telling the computer to do it in some respects. And this is actually a pretty good, I'd be quite happy if, for instance, adverts on the internet didn't just show me what I was just interested in, but show me what I was next interested in. You know, I go on to Amazon, I look for a bunch of, a new mouse, I go through a bunch of products, I buy one, and then all the recommendations are for mice. But of course I've just bought a mouse. Maybe next I'm going to want a keyboard, so they should be showing me keyboards that go well. So we're still, in many respects, quite dumb about how we're actually recommending things. So even though like Amazon are doing and advertisers are doing huge amounts of machine learning, and they have been for a long time, it's still quite difficult to satisfy our demand for better predictions. The levels of analytics. So descriptive is, this is what happened. So we sold 50 tubs of ice cream. We had an average profit of £5 per tub. These are simple things, and this is basically business intelligence. So it's not necessarily very clever, and we probably use this quite a bit in our applications. So if your app does something like supply chain management, then you might have the total sales and the total units needed and things like that. If you're just doing those simple representation of facts, then the analytics you have in your applications are descriptive. The next level up is diagnostic. Diagnostic is saying why something happened. So your supply chain app might show you the figures, and then it's split out by day of the week. So you can say, aha, I sold more on that day because it was a Monday. Diagnostic is actually really hard to implement inside a system. It's actually quite easy to skip over diagnostic and go to predictive. Predictive analytics is where you predict a value. So instead of just showing the sales by the day of the week in descriptive, you might go on to say, based on the past 5 weeks of sales, I predict Monday's sales are going to be this value. And that can be as simple as a rolling average. You don't have to do anything complicated to actually achieve predictive analytics. All you have to do is go from present to future. That's all predictive analytics is. Prescriptive analytics is actually much harder to achieve, because you go from saying, this is what I think a value is going to be, to saying, this is how you should achieve this value. So that might be going from, to maximize, I think your profits next week are going to be $1,000 on a single day, to saying, I think to achieve $1.50 worth of sales, you need to put on some promotions. And that can give you a lot of value, but it takes a lot more work. So those are the 4 of analytics. Very simply is just adding descriptive values into your application. Predictive is helping people forecast what values are going to be. And then the sort of top drawer of analytics is recommending what people should do inside your application. So why should you care? Well, one of the biggest reasons is profit, because especially if you can do prescriptive analytics in a way that increases how much people use, how much people buy, for instance, or if you can use it to save money, then your profit margin goes up, and more money is always good. User experience, if you can help people get to the purchasing or the knowledge or whatever it was they were after on your site faster, then the customer likes you more. So that's always a good thing. If you can put systems in place that help them, awesome. Security is one that I'm getting into at the moment. So we have had, there's a long-standing history of security flaws with applications. And security is really hard to do. Like just the other day, for the RSA security conference, they had an application for vendors to scan QR codes on people, and in their code, they'd put in the admin password. So somebody was able to open up the code, get this password, and crack open their entire database. Security is a hard thing, and especially when we're looking to authenticate users. The whole thing around biometrics, and I don't know how many of you have Windows phones, but I saw Andrew Fryer with his, and it tries to use facial recognition, and how in the early days of facial recognition, you could just hold up a picture of the person. So we can start actually getting smarter about how we let people onto our systems by using analytics, by looking at users' previous usage patterns and saying, does this make sense for them, and that kind of thing. And then the final sort of company-focused reason is it can help you understand your customers or your users better. And that can be a really powerful thing for the profit, UX, and security. So it's kind of a virtuous cycle. And then personally for you, well, okay, technology is accelerating at a massive pace, and it can be really hard to keep up. But we stay in IT because we love that challenge. And analytics is really hard to achieve in C#. So you're probably going to be using a whole bunch of new technologies. And that's really cool because we get to play with more stuff. And that's always good. Money, data science and analytics is really hot right now. And one of the sort of ongoing definitions of a data scientist is knows more stats than the average developer, knows more code than the average statistician. So if you can get yourself into the point where you're a really good developer who knows how to implement analytics, you can be in a really lucrative position. And then the final one is satisfaction. So if we're actually putting some of these things in to improve the user experience or making more money, then we have a job well done. We get the knowledge that we're achieving stuff and making significant difference. So that is a pretty cool reason to why you might want to put in analytics. Okay, so I've outlined a few cases, but I just wanted to go into more detail about ways analytics can go into your application for benefit. And please feel free to steal these and come up with your own. So the first few things are features, right? We've got things like Cortana and Siri are actually examples of analytics. They decode what the sound waves and convert it into text. It's a hell of an impressive thing. So adding speech to text into your applications is pretty cool. One of the devs in my current job, he was spending the weekend using speech to text libraries to build a remote for Spotify. So he could say, hey Spotify, play Kanye West. I then told him what he should do is take it to the next step and use the Spotify API to look at the ratings of an artist, and if it's particularly low, respond back with, are you sure? Really, so that can be how you can implement features that kind of, well, you could have fun, but can improve the experience. Facial recognition, the how old am I apps and stuff can be pretty good. I was reading about how some really cool stuff has been happening with Connect and how they can recognize, researchers were using Connect to look at autism in children, and based on facial patterns and movement patterns, they were able to diagnose autism. We might not all be able to do some highfalutin stuff like that, but the ability to put in facial recognition can do things like eye tracking. So if I'm here and I'm looking at my screen and I move my eyes upwards, then maybe we could move change the focus on the app. Recommendations are a classic, and we're still learning how to do this well. The recommendations are always good, whether it's you should buy this product, or here's this relevant coupon or this relevant article, to why not improve your use of the app by setting this default? It doesn't have to be a recommendation based on purchases. It can be a recommendation based on the app utilization. And that would be where analytics on your application could be really useful. And then adaptive interaction. So SwiftKey is a really nice example of this, of how I use my keypad changes the way that it autocorrects. You know, if a user always uses a menu as opposed to a nav bar, what about just ditching the nav bar for that person? What if we can improve their conversion rate just by removing the things that are extraneous to them? So Skype Translator, I don't know if you guys have seen this. So real-time translation. We're getting to the point of a Babel fish. Really cool stuff. And that is all analytics. It's speech to text and then text to speech. Very, very cool. Twins or not, alas, I am not a good replacement for Gillian Anderson. So this is based on the Project Oxford APIs from Microsoft, and it basically just analyzes the similarity of the facial structures to say whether two people look alike. What should I read next is invaluable for me. So I get through a hell of a lot of books, and that means I run out of authors quite quickly. And it can be really hard to discover what to read. So the recommendation on Amazon keeps trying to push me towards lots of bestsellers and romance books and whatever's cheap on Kindle. But I have a weird fantasy and sci-fi preference even within those niches. So the Amazon bookstore is just absolutely atrocious for me. I tried Goodreads, and Goodreads doesn't have very good UK coverage. So then I found what should I read next, and it's really good. It has some impressive algorithms under the hood to do recommendations, and as a result of putting just one book in, I've now read about 30 books based off the one list alone, and not a single one has been terrible. So this is an application that is purely driven by analytics. It's really cool. So UX, clever defaults. When if I've got a cookie on your site and I've used your site before, can you pre-populate some information for me? Can you set the menu to be focused on the things that I'm interested in? You know, you can use analytics to change the focus of the site or to help me interact with the site. Relevant ads, this is the mouse thing all over again. If I've bought something, I immediately want you to stop showing me the adverts for that thing, because I have absolutely no interest in seeing more mice. I've already gone through the buying process. And analytics can help with that. Adaptive marketing cycles. This was something I was thinking about, is if you're involved in the sending of coupons, newsletters, providing offers, then different people have different preferences. Some people are going to be discount-led, other people are going to be content-driven. Other people are going to buy on a weekly basis, other people are going to buy on a monthly basis. You get all sorts of signals through the website and through the data that comes from the emails that you could use that to drive when you send people marketing and which things to send them. So you can do some pretty cool stuff there that improves the user experience in a more holistic fashion. So not just the application, but the surrounding stuff associating it. And then a very classic example of analytics is when you're doing A/B or multivariate tests to try and improve the user experience, you can use analytics to assess whether things are winners or not. Security and housekeeping. So these aren't cool things, but they can be pretty good. So intrusion detection helps keep your app safe, whether it's early shutting down of denial of service or detecting unusual use by a user, like if the CEO logs in to your holiday database for the first time ever in 5 years. That kind of thing is worth knowing and flagging up. Clever authentication. If I'm on the same IP that I have been forever, then perhaps you should let me in without bothering me with a login screen. It can be troublesome getting if you have a public-facing website, you can end up with lots of accounts that are there for spam purposes, and they weigh down your database, they make things difficult. You don't want them. So having analytics, it's like effectively having a souped-up honeypot or reCAPTCHA system. Identifying these spam users before they make a dent on your real users can be really handy. And the same with malicious users. So whether these are people logging in and signing up because they want to do damage on your application or damage to other users, it's not necessarily very profitable, but it certainly makes a nice user experience for people. Fraud and error detection. Being able to cancel orders when they come through, when they're clearly fraudulent. Great way to go. It increases your profit. And errors. And this also comes back to customers might use your site in a specific way, and then if something really weird happens that isn't their usual behavior, then sending them an email to say, hey, are you sure you just bought this? It can be quite good. And then especially if you're doing social components to your application, being able to detect harassment, radicalization, cyberbullying, that kind of thing, that can be pretty handy from almost a corporate social responsibility perspective. I have here porn detection. You can get a nice nudity detecting API and just make sure nothing illicit ends up on your site, which can be pretty good if your application is aimed at younger people or older people who have some sensibilities. And then site monitoring. So having the analytics on the back end to say, my response time is going down. Is it going to end up in trouble? Or people are dropping off on this side of the site, or nobody's come in from here in the past few days. Flag this specific page up to management. All that sort of thing can be quite useful. And then I wanted to outline some other uses. So I worked for Mango Solutions, who are a data science consultancy, and one of the absolutely best business use cases of analytics that I saw was Mango were partially responsible for the taste of Kenko. Well, they're responsible for the ongoing taste of Kenko. So at DAO Craft, when they have DAO Egberts and Kenko and stuff, the coffee has to taste consistent over time. Because people like my nan who've been drinking Nescafe Gold for the past 20 years, they know the way it tastes. If I give my nan Nescafe as opposed to Nescafe Gold, she knows, because Nescafe Gold always tastes the same. And they would spend a lot of time and effort making sure it tasted the same, because coffee beans from different locations, the weather patterns and things would change the way it tastes. There might be soil changes, and the price of the beans fluctuates. So what Mango did was help Craft by, first of all, modeling the taste of coffee. So what do you need to achieve the Kenko taste? So that they could take beans and predict from a different, a composition of beans from here, beans from there, and beans from there, what the coffee would taste like. Once they had that, they were able to build the next level. They went from predictive to prescriptive and able to build an application which gave the internal users at Craft the ability to say, okay, here's my inventory. How do I optimize my inventory to make my Kenko taste like Kenko, but to make me the most profit? So it's really cool that analytics makes coffee taste the way it tastes. And we also did some work with the British car auctions to help them make the best out of when to sell and who to sell to. So lots of white Ford KAs go onto the market. They're going to sell really badly. But if you know what day to sell some of them on, when to send them to Manchester, not London, that kind of thing, it became a big application that routed vehicles to different locations and different on different days to optimize the profit. So it's what should I read next, where analytics actually becomes the sole or underlying driving feature inside an application. But you can still have analytics as peripheral features. And the link, bit.ly all 2015 vids. EARL is a conference on the effective applications of the R language. So pretty much every video there is a half-hour case study of how somebody was using analytics to make their company more money or to save lives, cure cancer. There's some fantastic videos there that can really help. And I wanted to actually highlight from some slides how Microsoft use R. So Microsoft have been using R since something like 2007 for Xbox. They help make sure that arena battles stay reasonable. It's really cool how Microsoft integrate R. And since then, they've been using it for more and more. And it's integrated into their Azure security portal. They're doing lots of analytics with it. It's everywhere in Microsoft now. And I'll cover R in a bit more detail later. But analytics is there inside Azure, inside Xbox, inside Cortana. Microsoft put analytics in a hell of a lot of their applications. Okay, on to tech. So, as I said earlier, I'm not going to tell you how to code your applications because some of you will have front-end apps, back-end apps. Some of you will be in the latest C#. Some of you will be stuck in the old ages. Some people might even be coding in VB. There's all sorts of nuances there that mean if I tried teaching you specific code, it would either be irrelevant, incompetent, or worse. So I'm going to cover things at a high level. And I wanted to split it out into things into the crawl, walk, run type of scenarios. I wanted to show you, first of all, things you can use which don't require any analytical expertise on your part, and then start working you up to more of the complex stuff. Because it's much better for you to try something with a low investment value and see how it works out, measure the performance before going on to more complex stuff, which takes more time to implement. So the best thing to do, first of all, is to use some black box APIs. So these are analytical APIs where you don't need to know anything but how to consume an API and pipe the results back into your application. So Algorithmia is a marketplace for APIs, and it has things like topic detection, nudity detection, geolocation, recommendation engines. Basically, there is an API for anything you could want, and if something's missing, then you can put up a bounty for somebody to come along and create an API for you. Datambox is a machine learning framework, but they have produced a bunch of APIs on top of it that do things like sentiment analysis or work out whether something's an educational site. So they have some pretty cool things in there too. Project Oxford is a whole bunch of APIs from Microsoft that power the what's my age, what breed of dog is that, and much more. They have a load of more serious use cases as well. Nowhere near as fun though. So you can actually get stuff provided by Microsoft, and IBM have Watson, which you might have heard about, which is their AI supercomputer that's kicking everybody's asses at every sort of knowledge-based competition in the world, and they have a bunch of APIs available as well. Then we have trained APIs. So these are where you use your data to produce an API online, and then you consume that API with your app. So Azure ML is actually really impressive. You have a GUI, and you can go through and pipe your data in, and then once you've trained your model, you say make me a web service, and it produces an endpoint for you to interact with, both on a single a single request or a batch basis. And because you can use R and Python in it, you're pretty much you have the entire gamut of modeling techniques available to you there. Google Predict and Amazon ML, they are much more limited, so they only use, you can basically only do logistic regressions with those. So they might be cheaper, they might be faster, but they're not going to cover anywhere near as many use cases for you. And BigML is another sort of machine learning framework. There's no GUI like Azure ML, but it's much more functional than the Google or the Amazon options. And I wanted to show you a bit on the Azure ML side. The Azure ML is pretty cool because it actually has a whole bunch of black box APIs, which aren't black box. So a whole lot of people have contributed APIs. So there's movie recommender, or there's you can spin up the web service that predicts whether a flight's going to be late, and use it to predict whether, when you're traveling to that next conference or you're going on holiday, whether you're going to arrive on time. And they have something like 800 items in there now, in that gallery. So you can do black box API techniques with Azure ML, and then move on to building your own GUI, your own model, and publishing it when you're ready to, when you need that next level of accuracy or speed. And then we've got streaming analytics. So when we're doing streaming analytics, we're using our current data and recent or past data to produce an updated value, and we'll usually access that via an API. So on the Azure platform, you have a whole load of options. They have their stream analytics, so you can do complex event processing in with Azure, and have things going through their event hubs. So that the Microsoft Stream Analytics is pretty cool. You can't really do things like neural nets or linear regressions or complex models, but if you want to do that descriptive analytics or some very simple basic, some very simple predictive analytics, then you can use Stream Analytics quite effectively. And then you have Storm and Spark. So Storm is another very good tool for helping you process events and produce analytics off the top of it, off the back of it. And Spark again is similar, and both of these are Apache open source projects that run brilliantly on Azure. Spark is my preferred tool, and I want to go into more details to why of the streaming technologies I'd recommend Spark. So Spark has a machine learning library, and so as well as being able to do streaming processing, you can do machine learning. And the really nice thing is that you can code it in whichever language you feel most comfortable with, so long as it's not C#. But they have Scala, Java, Python, and R. So if you get a data scientist or you want to move into that side of things, then you can use Python or R and do things. And this does really impressive distributed computing, and it is phenomenally faster than Hadoop. You can use Hadoop as a file store, but I would really recommend ditching Hadoop for any processing. Use Spark over the top of it, or Storm, or anything else but basic Hadoop for processing and analytics. And I was quite interested to read about how Pinterest are using Spark in their analytics. So they use Kafka for their event processing, and then they use Spark for their streaming analytics. And it's pretty cool high performance stuff that you can get out of it that you can't really get out of sort of base Hadoop. An interesting thing that I was reading about actually earlier was, I don't know how much you guys do SQL Server stuff, but one of the recent, I think they started in 2012 even, so it's recent-ish, but they have column store. So you can now effectively do a columnar database in SQL Server, and you can put those column stores in memory, so you can get really fast performance out of your database. And one of the things that you can do is, based on your really fast column store index, is you can be doing analytics over it and implementing that inside your app. So you can, you don't even necessarily need to be using these technologies. You could just be using SQL Server. And that brings me on to R, because R is now in database. So you can now do R in SQL Server as well, which is fantastic because so R is an analytical language, and you want to be able to do analytics. Previously in databases, Postgres has usually been one of the best analytical databases, and that's kind of meant that you can do linear regressions in it and not much more. But that was more than most of the other databases had. Now, with SQL Server being able to call R, you can do pretty much any model you want. Although I did see somebody not using R, but in SQL Server, code a neural net. So even in standard SQL Server, you can do some pretty impressive stuff with very unusual stored procedures. So you can do your analytics in your database, so analyze your data in situ, present, store the results somewhere, and then when you're using your application, call your model details to predict new values. That can be quite an effective one. In R, there is this package called Shiny, which produces really impressive web applications. No HTML, CSS, or anything required. So if you want to do prototype analytical applications or look at certain features, then you can use R and Shiny for that. As I said, I'm not sure if I mentioned earlier, but R can actually be used in Azure machine learning to code the training of the model and everything. And you can also use R with Spark. And one pretty cool thing is if you have a JavaScript fronted, a JavaScript heavy front end, then you can use the OpenCPU JavaScript library to call R inside your JavaScript. So if you want to simply do a line of best fit in your JavaScript in a chart that you're presenting to the user, then you can quickly call out to R with your data and just get back a JavaScript rendering of a chart, or just the JSON needed to squirt into your chart and present the data back. So R is my preferred tool of choice for most of my analytics. But that is coming from more of the non-developer side. So I find it easier to basically code in one language that goes anywhere. From a more developer perspective, I'd probably start with some of this, well, first of all, start with APIs that do stuff for you. As you scale up, then start looking at ways of getting analytics into your application through a sort of a streaming basis. Because you're probably, a lot of companies are investing in non-structured data stores and building architectures around streaming systems. Okay, so there's a bunch of others. TensorFlow is there's been a huge amount of open sourcing of different machine learning libraries. TensorFlow is one from Google, very impressive. CNTK is one that Microsoft released, and that's all about text, basically. It's fantastic for stripping bodies of text into component pieces and doing predictions. That the CNTK library is one of the was kind of one of the building blocks for their real-time translator in Skype. System ML, Torch, these are other ML specific, machine learning specific libraries. And then you've got Python. Python's a great general language and has some fantastic analytical libraries associated with it. So you can do really good things with Python. Okay, before we move on to the considerations, does anybody have any questions?
We're watching the chat channel there if anybody wants to drop a question in now. That snap to alignment stuff on the GoToWebinars are a bit difficult sometimes. Just slightly move them, they all snap together.
All right, well, let's crack on. So when we're implementing some analytical capability, irrespective of what tools you choose to use, there are some things you need to consider. So from an architecture perspective, one of the first things you need to think about is storage. Do you want to whatever features go into your model, so how you might predict or prescribe a value, you need to be able to store the features, and you need to decide whether you want to be able to do a write back, so whether you want to store the results, so what you predicted. Security, of course, you need to make sure that like if you're using potentially sensitive or personally identifiable information, like if I'm trying to predict a LIDNUG member's age, if I send over their race, gender, job title, and geographic location, then unless I'm sending that encrypted, somebody could intercept that, and they'd have a pretty easy job of identifying which LIDNUG member it was. So you need to think about how you secure and authenticate the data. It's also got to be scalable within your needs. So you don't want to have a really complex, computationally intensive neural net running on an 8 GB RAM i7 machine that's sitting under your desk because it was a prototype and it went live and your app went viral and you're now hosting 1 million requests a day. So you do need to think about your scale. Your architecture, you should be prepared to throw away your analytical components, right? Especially because you're going to be, it's always quite sensible to do the crawl, walk, run thing. And your first dabblings, toe dippings in analytics are probably going to be like your first steps in coding. In 6 months down the line, you're going to look back and think, oh my God, did I really write that? You really don't want to lock yourself in to a specific vendor or a specific technology if you can help it. You've got to be prepared to throw away stuff, especially because if the analytical components become core to your business and they become the way you can maximize profit, then you're going to be on the hunt for more accuracy, improved performance, and you're going to be doing a lot of changes of the technology, potentially even changing entirely which technology you use in order to be able to achieve that. And then the other thing that a lot of people fail to consider is how they're going to experiment with analytics. So if I have a bunch of APIs, a bunch of competing black box APIs that do sentiment analysis, and I want to trial automatic reactions to people's comments on my Facebook clone, then they're black box APIs. I'm not going to know how well they work until I actually put it into practice and I put it into my application. But if I put just one in, and I put it into 100% of my users, how on earth am I going to be able to tell the accuracy of it compared to just randomly guessing? You need to have some way of doing traffic management to your various analytical components, ideally. So that is something to consider when you're building your architecture. And you need a control group, really. So whether it's your base rule of thumb or just a random guess, it's always important to have a baseline for your model to compare against, because we'll see a bit later in some of the model considerations, but you really need some way of checking that what you're doing works. And if you don't have people who are not being subjected to what you're doing, then you can't verify that it's working. So you always want to have some people who are not undergoing your analytics in some way. So that was the underlying experiment architecture, and now onto the application. So on your application, you need to be able to manage the experiments, or at least associate people with the right experiments so that they continue to get a consistent experience. You probably want to give some thought to how you visualize stuff. So if your analytics focuses around, say, predicting, if you're doing a banking application, you might predict how they're going to spend their money or how they're using their money, and you should give thought to how you visualize that to maximize the value out of what you've done. Because if you stick it in a hideous chart that nobody looks at, then all your analytical work has gone in vain. You need to have some sort of feedback mechanism. So coming back to the sentiment analysis example, where you try and auto-predict how somebody is going to react to a comment, you need a way of knowing whether that reaction was right. So if they choose to not use your auto-reaction, you need to know that. Otherwise, you have, again, you have no signal that says whether your model needs refining. You need to be able to handle unusual results. So if I produce a model that gives me this age says, you know, the undercut in the hair says my C# developer's 21, but if they have a well-trimmed beard, their age goes up 5 years and stuff, then I could, based on somebody really unusual, I could end up with a very infeasible age for a developer. And when we build our applications, we need to make sure that we have some sense checking in there, that when or if our analytical component says a really strange value, that the application doesn't present that really strange value back to the user, because they'll rapidly lose faith in your whole application. And loose coupling. So you don't want, again, it's the whole walk, crawl, run. You don't want to have to cut, you know, strip thousands of lines of code out of your application when you overhaul your model, or just update it for the latest data. So you don't want to hard code things, and ideally, the whole microservices architecture thing works quite well. So, keep your analytical component behind an API endpoint. And then that way you can change your analytics however you want, but still get the same result back. So build that in. It's also, if you're using some, and you should also have try catch and retry capabilities in there. So, if you're going out to, or stuff that handles if you get rate limited, if you're using an external API. On the analytics, you want to consider how long something's going to take to actually develop, because it's usually better to get something simpler implemented sooner than it is to build something more complicated and miss the boat. You need to think about the data that is realistically going to be available to you at the time of predictions. So in a previous job, I built a rate for risk pricing API. And when I was building my model, I had this figure that went in, and it was great. Helped make my model more predictive. But it turned out that when people were first requesting a price, less than half of them were filling in this information. So it became kind of useless, because I couldn't give somebody a price and then change the price when they gave me this bit of extra info later, because we were in financial services. If I changed the rates, the whole financial impact was different. So I had to drop that useful figure, that feature, out of my model because the data wasn't always available when I was giving a price. You also need to think about how stable the data is. So whether this is you accounting for wage inflation, or if you base analytics, so if you require the average amount of listens to a podcast on your website to be sort of whatever it is right now, and that's kind of how you rule of thumb your analytics. But then your site gets a hell of a lot more popular because of your analytics, and all of a sudden the average is 250, then that whole feature that you were using that relied on that average has changed. So you need to be able to test for how the data changes over time and keep an eye on it. Now, another thing you have to decide is how important is it that you understand your model. So the really good thing about statistics versus machine learning is that with statistics, you've kind of had an expert think about what goes in and who can assess the output. So there is much less risk of garbage in, garbage out. If you just chuck your whole database at your computer and say, predict me something, and it comes out with something and you can't check the figures because it's a complicated neural net, then you don't understand how it works. It might be very predictive, but you can't really check it. You can't sense check it in any way. You might be comfortable with that, but you have to make sure beforehand that you understand and the rest of the business understands that if you use a more machine learning approach, that whatever figure comes out, you can't necessarily explain. And from my experience, people we all like to understand how something works. So if I implement a neural net model and then I say to my CEO, oh yeah, this happens, then they're not necessarily going to have a lot of faith because they can't understand it. So it's something to consider when you're doing your analytics. And candidate models. So this comes back to what I was saying about experimenting. There's more than one way to skin a cat, and different types of models have different advantages and disadvantages. You don't want to necessarily lock yourself into just one model. So building a few different ones that try and do the same thing in different ways is really useful. It helps keep your eyes open whilst you're doing the development, but it also makes sure it also gives you things to test so that you're not stuck with one solution that might just fail when it goes in. Especially because if you implement something, then you really want to hope it works. And this is kind of why averages don't work so well. And at this point, you might want some corpus analysis and NLP, natural language processing, to identify app did not warn me about tornado. And I really do recommend just not trying to implement something like TensorFlow straight off the bat. It is, it's like anything where you go, oh my god, this brand new technology, I so want to implement you, without thinking about the business reason first. And it is always, always better to implement something simpler sooner. Okay, so we generally shouldn't be doing things without checking that they're the right thing. So when we're looking to implement analytics in our application, we should, before we start, kind of have some way of, have a definition of done and have some success criteria. So if I want to implement my prescriptive analytics that suggest in my shipping, in my logistics app for my company, that they need to order extra stock on specific days, and I'm telling them which stock to order, then perhaps what I need to consider as my definition of success is, does the amount of last-minute orders drop? So I need some way of checking that actually what I'm doing is being useful. You need to be considering whether actually the extra computational costs are worth it. Because if I have a complex neural net model that spends 8 hours a night over 3-4 machines retraining, and that's costing me £100 a night, say, if I'm not making like £200, £300 a day profit, then there's not really much point. for all that extra effort. So you need to keep an eye on the trade-offs of doing analytics versus the value you get out of it. You need to keep an eye on drift. So drift is where your model ceases to reflect the behavior of the things it's modeling. Usually because you might be modeling people, and people change, economic situations change, a whole bunch of factors will change the way that people behave, and you have to do what's called recalibration. So you basically just have to say, with the latest data available to me, what should my model be like? You know, do I downweight this factor? Do I upweight this one? If you're doing so many of the machine learning modeling techniques will basically retrain either daily or almost at every request. So if you're retraining at every request, then you're not going to suffer from drift, but there is the risk of suffering from overfitting. And overfitting is where you're very, very accurate on your previous data, but your previous, and you're so accurate that everything is just geared towards being accurate on your past data, and it doesn't actually work on your on future data. And you need to be careful that when you're measuring success and sort of analyzing the impact of whatever analytics you've put in, that you're taking into account the other activities that might be going on within your application. So for instance, if you decide to send 1 in 10 of your traffic to your new predictive model for predicting how they're going to spend their money, and the new visualization associated with it, and you take you do a modulo of their IP address, so it's always 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9 at the end. And this is exactly the same method being used to decide who gets to see the coupon and big sales offer when they come into the website. You've got now suddenly 100% of the people who are seeing the coupon seeing your new model. You no longer have a fair assessment of your model because they're being impacted by something else. So you need to make sure that if other things like that are going on, that everything is randomly distributed, so you don't get other things busting your analysis of your analytics. Okay, so that's pretty much it. Kind of gone through what some of the buzzwords mean, why you might want to do analytics inside your application, what sort of things you can use analytics for, what techs you might want to consider using for it, and the sort of things you want to think about when you're implementing analytics. Because you want to do it right. Otherwise, it's it's a big waste of your time and can even be detrimental to your application if you don't give it decent enough thinking. So I blog on itsalocke.com. Yeah, you can follow me on there. I'm on Twitter, and you can get this slide deck on GoToWebinar. It's available in the handouts section, if you can see that, and it's also on OneDrive to be downloaded. I've got a question from Dan. What was your most interesting visual representation of analytics you've worked on? I've actually been doing some stuff at the moment. So SensorNet, the company I work for, they basically built about 10 years ago, they built a web proxy. And they've been they were a two-man band for a very long time. They got a venture capitalist, got involved, gave them an injection of cash. They have been able to hire more developers, and they've been building some stuff, but there's no intelligence in their products. So that's why they hired me. I'm there to put analytics inside their apps. So one of the things I'm doing at the moment is looking at their data and looking at the analytics I can put in. So it's very visualization intensive at the moment. So one of the things that I had a rating system for different cloud vendors, cloud application vendors, and I started off, because there are a number of factors, but I had two scores that were kind of underlying components. I made a 3D interactive JavaScript visualization, so like 3D scatter plot with the things colored, and it was really cool because you could pan around the turn the chart, look at it, select different apps and kind of have them disappear from the chart, and it was really cool. It was a very nice thing to play with. In the end, I went for a much simpler representation. Instead of showing the two score components and the final score, to showing the two score components and then the color encoded, using the color of the dot as the final score. And that actually worked better because it was easier for people to understand, so they saw the distribution sooner. And I usually find simpler is better, but what I can do is show you some cool stuff I'm doing right now. We're doing some beta testing at the moment. So I've been able to, and this is using R, we're doing some simple analytics and looking at ways I can represent the data. So these are just simple digraph JavaScripts. What I've been able to do is looking at dodgy activity. I've got three charts on dodgy activity, all got the same dates, so it's all mapping the same data. And what I'm now able to do is zoom, and the user will be able to do this. They'll be able to zoom in and actually see what's going on. And all of these charts are linked. So you can, there's some really cool visualizations out there. The ones you need are the ones that suit the situation. But I think I'll definitely be implementing these within the app when we do the allow customers to compare themselves against other against the rest of the cohort, so other customers.
Still, Steph, there's another question or two there coming in.
How can those with BI systems with an ETL pipeline doing descriptive analytics move into prescriptive analytics when external API are not an option? Okay, so if you're producing high-level descriptive stats and you've got things like counts and sales, then you can actually use those as the route to doing analytics, more predictive and then prescriptive analytics. So let's say you're compiling your sales data from lots of different point of sale systems, and you're getting this data in from different sites for different customers, and you want to start you might first of all, with all the summary data, start predicting their sales. So you have a value, and it might be dependent on a time value, a customer, number of other tills on the site and stuff. So you could add an extra layer to your ETL that once you've done the transformation into summaries, that then uses those summaries to build a predictive model. If you're using SQL Server, so integration services, you could actually execute that as a linear regression inside your SQL Server now, store the results, and then consume the results in your application. So that would be the simplest thing to do. And then to move that into prescriptive analytics, so once you have models that predict values, you can then add the next layer, which says, now that I can predict these things, here's how I should optimize it. So say you are a chocolate company and your ETL takes your data from your inventory systems and your manufacturing systems and your sales systems. You could first of all predict demand, and then again the simplest thing is to be using R or Python. You can call it either from SQL Server or from C#. So you then have your application, your little analytical app, which says, okay, so I can predict how many sales I'm going to make next week. I know how I can predict I know what needs to go into my chocolate. So how do I optimize my inventory to meet my predicted demand? And then you can store those results, or you can stick it into something like Message Broker or Database Mail or something that then goes on to say, and tell manufacturing to turn on the chocolate mixers. It's a long process though, And it's usually best to start with doing the predictive bit first and then go to the prescriptive bit once people have faith in the things you're using to, because otherwise you'd go through all the effort and people wouldn't really use your answers, which was actually a big problem with the financial crisis. There are a lot of models out there. Some were wrong. Some were saying everything was fine. But there were a lot of them that were saying they were heading for problems. And people didn't believe them or had reasons to ignore them. And they made very bad decisions as a consequence because they didn't have faith in the models. So you need to build faith in the predictive bits before you can do the prescriptive bits. Any alternative to spreadsheets or CSVs for this? What other ways? Simply amp up the axis bar with either cube or just row column. Dan, I'm not sure I understand. So I try not to go from spreadsheets where possible. Obviously, it's unavoidable for most of the part. But one thing it's really good if you can get your hands on the operational data. I'm doing a lot more with JSON these days, from integrating data from different feeds, because it's an interesting position now where there are so many APIs out there available and with cloud services and stuff that you can have very little of your own technology and you can just bolt all these different things together. So being able to pull and represent data from JSON is a really vital skill right now because it's how the internet talks these days. I was reading on the sources for data. I'm not sure if you're talking about cubes. I was reading some very interesting articles on the MSDN blog about using column store as the data source and then sticking analysis services over the top of the column store index using direct query. So not necessarily building, so having a cube which goes straight to your operational data that's in column store and using that in Power BI or as a source for your application to produce your visualizations and analytics. And that's a really cool technique because that's no extra cost because you have all the components, and it then means that your model is also consumable. Your analytics is also consumable by end users in Excel and things, but it does limit you as to what you can do in terms of modeling techniques.
Anybody else got anything to ask? That's great. I've got one thing for you, Steph. When in the architecture of these systems, because obviously you have a lot of API calls going along with systems these days, especially when you have apps that are dynamic web
Chatty
pages.
apps.
Yeah. But so you have the calls that actually make the app work, the functional stuff. Then you have the analytic stuff going on. In your architecture designs, does the efficiency of those analytics systems move you away from, because you spoke about JSON, because a lot of people use JSON. But I come from an ISAM-based background, where the speed of the data far outweighed just being able to read it straight off the cuff like you can with JSON, because JSON is just human readable. Do you come across that a lot, or is it very much just the JSON HTTP text-based calls fine?
Yeah, I've done XML representations as well, but for the most part, it's communicating with JSON these days, unless you're doing it in database. At which point, you're going as fast as your query can run, and you have then the direct interaction between your, if you're using something like Entity Framework, get the results back.
Yeah, of course. Yeah.
And it works. But yeah, it's mainly JSON.
Mainly JSON.
External API.
Yeah, I was talking about it with somebody the other day, but yeah, it's. Have you seen the IoT Hub yet? Have you looked at that at all?
I've not looked at it in big detail, mainly because Internet of Things is something I'm getting into. The most I've gone into it, we now have Hue light bulbs, and I've set it with if this then that, so that whenever I tweet, it changes the light colors in my house.
Okay.
So that my husband had a wife watcher, because whenever he seems to use Facebook, I get a notification, and he didn't get anything like that. So that is kind of how much I've got into Internet of Things is an if rule. It's on my to-do list.
Okie dokies then. I don't think there's any more questions coming, so we'll close it there now. It's getting on a bit there now for yourself. But no, thank you very much. There's a lot to learn from there. There's some things I'm going to be taking away from there. I think I'll watch it back again later once I've processed that video, and lots to think about it. Especially one of the last applications that I built was for a BI company, but I was just doing the application development. I wasn't taking part in the BI, but that just being the dev amongst 100 BIs. It's good stuff. So thank you everybody for coming. There's a couple of people on there already, but thank you very much. And of course, this will be is being recorded and will be on YouTube shortly. And again, thank you very much, Steph, for hosting tonight. Much appreciated.
Oh, thank you for having me. It's really interesting that we're getting to this sort of convergence point. Where I used to be in BI, it'd be like, oh no, can't talk to the developers, we're not allowed to talk to them, or the developers are like, oh, those BI people. Yeah. Whereas now we're all just coding and getting along, so yeah. I like that.
I come from a designer background, so that's why I end up mostly doing front ends or universal apps, but yeah, it's exactly the same thing. Designers had one room, developers had the other, and no one saw each other unless it was the Christmas party. That's pretty much it. Right, I'll stop this. Right. Thank you very much, everybody, and good evening, good morning, and good night from wherever it is you're logged in from.